We give you a view here. Unfortunately, it's upside down, but that's just because I got the camera mounted on a homemade mount on the second shelf of my workbench. So this is the next day now, and move these tools out of the way. Get this stuff out of the way here. So we get the tools I need here to do the job. Now, what I brought in is a computer cord. I've got a bunch of them, so I'm going to sacrifice one because I need the 3-prong plug. So, get that out of the way here. And the meter is in, and silicone is all dried out. It's fine, it's set up, I should say. Oh, we'll put this box under here. And a little peek in the camera here. Yeah, we're in view here. Okay. This is becoming a, I believe this is part 5. Becoming a long video. It takes a long time to build something and almost design it. Let's put this under there, get it a little more level. All right, what I got to do here, the meter's in. All right, the bezel is siliconed in place. What I got to do here is to cut the cord. I got to establish where I want my cord to come out and how much of the cord I want to go into the edge over here. We're going to do that first before we start doing too much wiring here. I'd like to use some of these wires again because they have nice connectors on them. They're soldered well. I might be able to, I'm not sure though. So the first thing we're going to do is we're going to cut the wire. We don't need to record every single second of this. We'll come back on this when I get the wire trimmed out. We'll feed it through here. And then we got to find some thin wires to go in here for the meter. And then we've got to get the sensing coil hooked up. But that's at the end. We don't want anything to happen to it and get damaged. And these are the outlet wires right here. The neutral and the hot. And we got to get those terminals made up. Now, we'll come back in a minute here. Alright, we're doing some figuring out here. Alright, this is the slider or the wiper, whatever you want to call it. This is the sensing coil for the digital meter. Now, this is supposed to go to the amp meter. And the amp meter, of course, is in series with the load. And then there's a jumper from the amp meter to the voltmeter. But we've got to feed this through here like this. And then connect this on here. But before I can do that, digital meter's over here. I'm going to have to extend these wires, and I don't think that would hurt anything. They're very, very thin, but it's only a sensor. So we can get the amp meter part to go through. Now theoretically, you're supposed to go through the center as much as close as possible. But sometimes that's not possible. But what I got to do is extend this before I can do that. Make that connection down here. So what I am going to do is leave this off for now and do that last, because that's very delicate. I will connect the wiper of the Varac to, oh wait a minute, now we got some washers in here too, to the Varac, from the Varac to the ammeter. Temporarily, we're just going to stick these on hand tight. Because we got to place everything where it should be. So nothing is in stone, etched in stone right at this moment. I got the cord cut. I don't really need to talk that loud now. There's no AC on. I got the cord cut extra long here. But I got to make a terminal strip up, I think, so that I can couple these wires. This ground wire has got to go, as I said, right from this outlet right to the ground wire on the power cord. So it gets direct connected and mounted that way. I hope I'm not in the way here with this. Okay. I need the light more. I don't need the magnification, but right now. All right. I think that would probably go under here. There's two washers. In order for me to see it, I got to take off. They're not completely. So this jumper can stay on here. This was on there. I always like to use these connectors over again if they're made good. All right, I think we'll get that. We'll get the handle out. Tighten that up. All right, I gotta figure this crappy cord out. This is a I just got it clamped here temporarily so I can test it. This is what's inside of a computer cord. That damn thing's paper thin. And mongrel color coding. How the hell are you supposed to know what a hot is, the ground or the neutral? You don't. It's Chinese junk. I had to sacrifice a computer cord. It's got the 3-prong plug, which is what I want. You know, and it doesn't need to be real heavy. The max, I looked at the Varac. The Varac is a 3-amp Varac. I found the label on the side. Can't use standard color coding. They got to use oddball colors. Okay, we're going to use the old meter here. I'm sorry the thing is upside down for you guys, but I need to be able to read the meter. I got to find out what is ground on here, what is hot and what is neutral, because they're oddball colors. They use yellow, they used light brown and blue. That don't make sense. All right, let's see what we got here. We're reading into the megohms. That's mostly because of my fingers. All right, so the brown is not cold. I'm reading 0 on the yellow. I'm reading the megohm. Don't tell me the yellow is ground. That's what I got here. I'm right on the ground prong here. That is nuts. I'll tell you. Definitely knocked electrical code, that's for sure. Yeah, that's ground. Yellow is ground. That is crazy. All right. This is the neutral. All right, the light brown is neutral. Which means the blue is hot. blue is hot. All right, well, I've done a lot of wiring off camera because I've been working on this for 3 hours with my bad eyesight. I don't think you'd like to listen to the audio part of that video, so I didn't make it. I had to change the switch, all the jockeying around and everything else. The lug broke right off the power switch that was originally with this setup on the plastic box. But I got a new old stock switch that I had from my workshop, so that'll work out perfectly. And we're in the process of wiring it now. It's unbelievable how thin this damn wire is for the computer cord. Unbelievably thin and oddball color code. The yellow is ground, the blue is hot, and the tan is neutral. Figure that out. Well, anyways, here it is. According to my wire stripper, this is 20 gauge. That ain't no 20. That's more like 24. It's so thin. Now, the wires are really heavy here, heavier than they need to be. These are the original wires that were in here.
I retired these things many years ago. It's not hot enough yet. I don't like it. Got the wrong tip on it.
Well, I just took an ohmmeter reading and I moved this back and forth here, and it didn't lose connection, so maybe I didn't hurt it. All right, we can continue on the finalization of this part 5 here. Thanks to one of my viewers for kind of waking me up a little bit about the soldering gun. I took and this is my other soldering gun. I had 2 of them. The other one I threw out. The one I was trying to use with the oversized tip on it, because these bars here would get real hot and the whole body would get hot, no matter how tight I made these nuts. So there was obviously something wrong somewhere inside, I guess, and the heat kept shutting off out here. So I used to do this years ago. Well, this is number 12 wire. I used to use number 10, but I don't have any 10 scraps, but I do have 12. So you just make actually I'm in camera here. So now I was able to finish up the soldering of the switch. All I had to do was solder the switch here and the paper thin wires here, the hair thin wires I should say, of this computer cord. I can't believe how thin these damn wires are here. Super thin, but I have so many of these computer cords, I sacrificed one, and I didn't want to deal with making one up with a plug and wire and everything else. I wanted something that was already made up. So if it was a 2-prong plug, I'd have no problem. Well, anyways, I put this terminal strip in, and that carries over all the wiring I need, but I'm only using one part of it right now, but that's okay. And because this wire is so thin, this blue wire is the hot wire. Isn't that something? Like I say, the crazy coloring code they use on these things. So because it's so thin, I had to put a wire tie around the body of the fuse holder after I soldered it here to just keep things in line here. Over here is the sensor for the amp meter for this digital meter right here, and the wire is so super thin on this here. It's got to be number 26 wire. Unbelievably hair thin. So I made a little extension out of some 24 gauge wire, I believe this is, and used a little, put some tape and put a little piece of heat shrink, but it fits so tight I didn't have to heat it up. So all I got to do is secure this down so it's not flopping around. Last night I put silicone in here and siliconed this in. If you look here, this is the main off the wiper arm of the Varac. This is the load wire, and it's pretty well centered in the coil here, as best I can get it. And you see it right there? That's the coil. I use silicone. I use some black RTV silicone in there to hold that in. So everything is all set and ready to be put in place, I think. So what I'm going to do is I'm going to mount this. Now, I found out, I forgot all about, there's one bad thing about this digital meter here. When I reduce the power on this, the display goes real dim. What a bad design. I thought this was, the light was 120 volts and it stays that way, and the voltmeter would vary, but not only does the voltage vary, but the backlight of the meter gets dimmer and dimmer as you turn this down, so it defeats the purpose of having a damn meter in here in the first place. But it's here. I cut the hole out for it. Let's get it mounted in. Well, I forgot about the plate. We got to put the plate on and the knob on yet. So I'm going to do that off camera. Well, I never had much faith in hot glue, but I did use it here to hold this wire down into place. When I went to put it on here, it hardened up so quick that the plate was just rocking on the panel. We'll flip this over and we'll put the plate on it. And what we're going to probably do is to put the plate on it, let it set, take a lunch break, and hopefully it'll stay in place long enough that I could probably maybe put the knob on it. But I don't want to put it up here yet because I don't want the plate to fall off. Silicone really needs 24 hours.
Are you 100% sure about that?
I had to put a second coat of contact cement on there. Would you believe I went to apply this and it just fell right off? So if this don't do it, I'm going to get silicone on it, and I guarantee you that will hold it on. The super glue hardens up too quick. I mean, not the super glue, the hot glue, which I had left over from my workshop. And it did good on that little wire inside, but it's no good for big surfaces like this. It sets up too quickly and it doesn't work. I'm not sure what he used, whoever made this thing up on the original radio cabinet. I don't know what he used, but it looked like hot glue, but it couldn't have been. It must have been some other kind of a glue or something. But anyways, we're letting it sit here. So we go about 15 minutes, I guess, on this. And we'll stick it on, and then I'll try to get the knob on. There's 2 set screws on the knob. This is the switch I was talking about. This is the original switch that came with the setup that I had that was in the plastic case. And with all the movement around everything, it just snapped off the lug completely off the switch. So I had to put this switch in. So far it's reading continuity, even though the lug is a little loose from trying to solder that. So yeah, this worked out good with a homemade tip on it. I used to do that many years ago, but it was frustrating with all the soldering irons I had, including another one that someone sent me. It was only a 35 watt. It just would not do that kind of work. So like I say, you need 60 watts at least. A gun is good, but my argument is not so much for this project, but for a lot of projects, a gun is way too big, and that's why I went to a soldering station years ago. You can't go using a gun on small equipment, even on this. You got to get in on the wafer switches and work on the wafer switches and change over parts and stuff. A gun is just too damn big and bulky to get in there. On the back here, I had thought of putting a piece of sheet metal, but it's not really needed. There is no real heat being generated. 3 amps is the max, and it's not going to be anywhere near that. It's more near 1 to 2 amps maybe. And the back of end of this Varac here is 1.25 inches from the back wall, and that's the closest part of this board of any component getting near the wall, so we should be okay. After all, tube radios are made in wooden cabinets, so what the hell's the difference? Tubes get a lot hotter than this Varac. A Varac could, if it's under load, probably just be warm. Well, we got it on, but there's a problem. Story of my life, there's always something going wrong. I wired this up exactly the way I found the wiring, except that I put the variable on the hot side, not the neutral, and the switch, because the way whoever made this up had the switch on the neutral side, and you never switch the neutral, even though, well, it's not isolated, so you don't want to switch and vary the neutral. Well, there's a problem. It's all the way down now. I'm reading 119 volts. But watch what happens when I turn it clockwise. The voltage goes down. I guess I could live with that. $33 volts. The meter actually goes out at 30 volts. It's supposed to be 0 to 300 volts, but the back of the meter says 80 to 300 volts. So it's reading 30. I don't know if you can actually see that. It don't show up very good in the camera, but it actually looks better in person. So this dial is rated in percentage. So there's my voltmeter. You can't even read that. It's about 40 volts, 45 volts. But another thing too is the display gets brighter as you turn up the voltage. Well, there's a certain range here at which it don't change. But as soon as you start going around 40 volts, you get about below 40, 45 volts, then it gets dimmer and dimmer and dimmer, and you're at 28 to 30 volts right now. So, what the hell have I got to reverse here? Let's see. I got to do some thinking. I don't want to have to wire this whole thing up again. I think I can just make one correction, but the problem is the wires are all fitted in there nice. There is a lug, as you're looking at it, where it says no connection there. Now, there was no connection there, because I marked everything in that little diagram before I took it apart. And the wiper is the one to its right, which is the load wire, which goes through the load coil and goes up to the amp meter. So I hooked everything the same. The only thing I did is put the fuse and the switch on the hot side, in which case, as I said earlier in this video, this blue wire is the hot wire. This is a computer cord, which has got super thin wires on it. But this is the hot. I did not want the switch and the fuse in the neutral. So we can't mount this unless I want to go backwards on the Varac. It's only a percentage dial anyways. But normally when you turn a dial to the right, it increases the voltage or volume or whatever kind of a control you use. It's just the way they work and the way you use things. It doesn't mean it has to be that way, but I would rather have it so if I turn it to the right, it's going to increase the voltage, and I turn it to the left, it'll decrease. Well, right now it's just the opposite. Okay, Apparently I'm going to have to live with it. This is the slider right here, which goes to the amp meter and is the load. The amp meter's here, goes to the voltmeter. If I put my meter here on this no connection one, I'm getting 20.85 volts, and that does not change when I rotate this. Alright, I'm just changing. Alright, I'll give you the reading on that. It's still the same. Okay, so I can't take this and move it to here. I don't have a schematic of this. There is no schematic of this Varac, but it should be pretty easy to figure out. Alright, there's another one that says no connection. And that is the same situation. That is 96.5 volts. That also does not change, and I will prove it. I will turn this, okay, read that on here. 96.6 volts, that does not change. So, there is no other taps on this. Let's just look on the other side here to make sure before I open my mouth. Nope. There is no other taps on this. Okay, so this is your line. In this case, the hot side of the line is going in here. This is the hot side of the line. This is the neutral side of the line. So your line goes across here. And this is your wiper right here, which is probably live. All right? So there is no way to reverse the rotation so it would go the other way. So I guess it was always backwards. You turn it to the left to raise the voltage, and you turn it to the right to increase the voltage. Now, I would imagine, I wouldn't want to try it though, because I don't have a schematic of this. I don't want to take it out. I got contact cement in there holding the plate in. I'd have to break all that away and get the bolts out, take this out. I'm not going to do that. I imagine I can probably take and swap this to this, but I don't think so. I think this is the end of the coil right here. I'll take a piece of, because this is still plugged in, take a piece of heat shrink here. This is the end of the coil here. This one is probably the end of the coil for here, although there's no connection on it. I don't know if taking the neutral wire, which wouldn't reach, I don't think, and going over to here would make any difference. But the highest this will read, this Varac will only go up to full line voltage, in which case I'm getting 118 volts, 117 volts. You can't get it to go any higher. Some Varacs will give you an increase in voltage, but without a schematic on this Varac and without me pulling it out and looking on the inside, which I don't think shows too much anyways, I'll just live with it the way it is. I don't like having it going backwards like that, but this video is becoming too long. Okay, it's in there. Looks pretty good. The switch works. The voltmeter works. Well, we don't know about the amps yet. We're going to try that out. But we're all the way over to the left. See? We're all the way, and this dims down. It starts dimming down once it gets about 45 volts. But the meter will read down to 30 volts, which is all right, because when you're down to 30 volts, you can't even see this. So we're at 35 here. I don't know if you can see that. This shows better in person than it does on the camera. But we're 35 here, but you really can't see that. So we got to remember to turn it left to get it up. That's why I like the digital. I'm reading 43, and I'm reading 40. So that's close enough. Oh, all right. Let's try it with some with a load. All right now I'm reading 119 volts. All right, this soldering iron here. This is a Weller 8200N, I think. I don't have my reading glasses on again. This is supposed to draw 1.2 amps, so I guess it's at the 140 watts setting. 1.2 amps. And I'd have to get my spectacles on here. All right, we're going to fire the gun here for 140 watts. All right, she's reading between 1 and 1.5 amps right here. And 1.2 amps, so the amp meter's working. So the only complaint I got on this is the voltage is, turn it to the right, the voltage goes down. Turn it to the left, the voltage goes up. All right, we can live with that. I mean, what the hell? We can live with that. That's it on this project. The only thing I forgot to do is to put the little fuse in for this. I will do that off camera. That's not a big deal. I just wanted to... It's not going to really hurt anything if the wires are so thin on this meter that if anything happens to it, it'll just blow out internally and it won't cause any major problems. So, okay, I think that looks pretty sharp, if I do say so myself. What do you think, guys, huh? You think the old goat did something good in his life for a change? Or do you think he's full of crap? Thanks for watching, guys. I appreciate it, and I appreciate all the help on all my little problems here, big problems, and all kinds of problems. Thanks again. And if there's any modification to this, if I can figure it out, I don't think there's no changes that I can make on the Varac that'll do it. I showed you what those taps were, and I don't feel like pulling it out because I'd have to break the glue, and then I'd probably bend the aluminum plate getting it out again in order to get those 3 bolts out. It's a big job. I had one hell of a job getting those 3 bolts lined up there, and I don't want to deal with that again. So, okay, so we'll turn this down about halfway. We'll flip the switch off, keep everything off, and that's it for part 5. Thank you for watching.